Hello and welcome to the Chandar Academy. In this video, we are going to solve the second part of this classic exercise about a study of function. In the previous video, we've solved the first three questions. Here we will solve the question 4 and 5. Let's remind a little bit the past results. We found that the domain of definition of f is equal to R, but so without the element 1, because in 1 we divide by 0 here, and for all x's in this domain of definition we have f of x is also equal to x plus 3 plus 5 over x minus 1, same thing. Then we prove that the limit of x in plus the infinity is equal to plus the infinity, in minus the infinity is equal to minus the infinity, in 1 minus, so just before 1, the problem, this is equal to minus infinity, and in 1 plus, this is equal to plus the infinity. Now we will want to find the vertical and slant asymptote of C. Let's start with the vertical asymptote. For all these rational functions, we see that the problem is when we've got 0 at the denominator. And at the denominator, we will find a vertical asymptote. We see that just before 1, we go to minus the infinity. So if my graph is something like that with 1, just before that, I will go to minus the infinity. And just after that, I come from plus the infinity. And our vertical asymptote will be this straight line here of, so vertical line in going through the point 1, 0, and this line has an equation of x is equal to 0 because these are all the points satisfying the equation, x is equal to 1, because on all these points, x, which we can read here, is equal to 1. And so our vertical asymptote, the vertical asymptote to C, which is the curve of f, so the graph of x, has an equation of x is equal to 1. We have solved this part of the question. Now, what are the slant asymptotes? Slant asymptote means that in plus and minus the infinity, our function will behave as a straight line. And what can we see here? We can see that in question 2, we proved that f is equal to the equation of a straight line plus something that will go to 0 in plus infinity. And this means that this little thing here is our equation of a straight line. Okay, and how do we prove that? So second part of the question, let's call y1 the supposed slant asymptote to C. Okay, so we just name it and we suppose that this is the slant asymptote. We are going to prove it just now. To C, and y such as, and we are giving the equation now, y1 given x gives what? This thing here. This is always the same thing, and this is a very classic exam, x plus 3. Now let's study f of x minus y1 of x, and this thing will be equal to x plus 3 plus 5 over x minus 1 minus x plus 3, and this thing is equal to 5 over x minus 1. And we clearly see that the limit when x tends to either plus or minus the infinity, okay, so both infinities, of f of x minus y1 of x is equal to, so this thing will go to plus or minus the infinity, and if we divide 5 by plus or minus the infinity, we will find 0. So this thing is equal to 0. And we conclude, this implies, so we conclude that y1, that given x gives x plus 3 is the slant asymptote, sorry for my writing, of c in plus minus the infinity. Okay, and now we have a lot of things. We have solved the fourth question. Let's solve the fifth question and then graph the sketch of f. Now let's study the variation of f. So we will study the variation of f going through the study of the sign of f prime of x. Of course, f prime of x exists. F prime of x exists for all x in the f. Let's remind the expression of f of x is equal to x plus 3. F is equal to x plus 3 plus 5 over x minus 1. Let's derivate this function. F prime of x will be equal to 1 plus, what is the derivative of this? The derivative of this is 5 times minus 1 minus x minus 1 prime, which is equal to 1 over x minus 1 squared, which is equal to 1 minus 5 over x minus 1 squared. Now let's study the sign of this expression. We want to find the values such as f of x is equal to 0 if prime of x is equal to 0, which is equivalent to 1 minus 5 over x minus 1 squared is equal to 0, which is equivalent to 1 is equal to 5 over x minus 1 squared, which is equivalent to x minus 1 squared is equal to 5. This is equivalent to x minus 1 is equal to plus or minus square root of 5. And finally, that x is equal to 1 plus minus square root of 5. 1, so x1, let's call it 1 minus square root of 5 will be lower than 0, okay? Because this thing will be greater than 2, which is square root of 4. So we will have something 1 minus something bigger than 2, which is lower than 0. x2 is equal to 1 plus square root of 5 would be greater than 0. And we can even say that it will be between 3 and 4. And this will, and 4, and this, here x1 will be between 0 and minus 2. Yes, minus 2. Okay, now that we have both things here, when we have x outside of x1 and x2, so x outside of x1, x2, what do we have? We have something that is positive. Why? Because when we've got x that tends to plus the infinity, we will have 1 that is positive. And so because we know that it does not change of sign, we know that This implies f prime of x greater than 0. Okay, now that we have that, we can set a little table of variation. X, f prime of x, f of x. Perfect. What are the important values? Minus the infinity. The other important value is 1 minus square root of 5. The other one is 1, because this is the value where our function is not defined. We write it like that. And finally, 1 plus square root of 5, and finally plus the infinity. Okay, we know that the derivative is equal to 0 in these values, and that we've got something positive outside of the values and negative inside of the values. What do we know about f of x? We know that in minus the infinity, it is equal to minus the infinity. In plus the infinity, this is equal to plus the infinity. So we've got minus the infinity, we've got plus the infinity here, and in one, what do we have? In 1 minus, we've got minus the infinity, and 1 plus the infinity. And so we've got here minus the infinity, and here plus the infinity. And this goes along what we found for f prime, because here we will have something growing and then decreasing. And here decreasing is equal to 0 here, and then growing. And here we will have f of 1 minus square root of 5. I do not care about the value, okay? You can calculate the value if you want. I will not do it to not make the video too long. Plus square root of 5. Please calculate the values of f of 1 plus minus square root of 5, okay? Calculate them, because you are still a student and you will have to do it in your exam. Okay, so now let's graph the function. We've got our y-axis here. Okay, we've got our x-axis here. We've got the forbidden value 1 here. Okay, so let's say that this is 1, this is 1, minus 1, minus 2, and here 1, 2, 3. Perfect. Now let's write down the slant asymptote. So here, let's say that, okay, this is equal to 1, 2, and 3. So let's draw the slant asymptote, which has a direction of 1, but that goes through 3 in x is equal to 0. So here is x, this is x plus 3. Okay, so this is the graph of x plus 3. I will just try to make the graph bigger. Okay, so let's put it down so we can keep going up. This is the graph of x plus 3. Perfect. Now what do we know? We know that in plus minus the infinity, we go near x plus 3. So let's graph it in another way, which will be simpler to see. Okay, so this is x plus 3 here. Now, we know that in minus the infinity, we go near this value. Same thing in plus the infinity, and so f will go near it in minus and in plus the infinity. We know that in 1, let's say that here we have got 1 minus square root of 5. We know that we change direction. Same thing in 1 plus square root of 5. Let's say that this is here equal to, let's say that this is equal to f of 1 plus square root of 5. We will change variations here. And we will go in minus the infinity in 1 minus. Okay, so this is our asymptote. This is our asymptote. In 1 minus, we will go to minus the infinity. Okay, so here going from minus the infinity, change of direction here, and then going to minus the infinity in 1. In 1 minus, in 1 plus, we go from plus the infinity, changing directions here, and then going near our asymptote. And here we have the graph, let's call it CF of the function f, which is in 2 parts. The first part just before our vertical asymptote, and the second part after our vertical asymptote. If you can make the graph a little bit bigger to really see that we come near the asymptote, it is even better. Here I would graph it more like that if I had more space. Here, perfect. And here we have the graph of f. If you want to see it a little bit better, here we are, C of f. Of course, we've got C of f here as well. And the value 1 is absolutely forbidden. And here we have solved the whole initial exercise. Hope you enjoyed the video. See you soon. Bye.